Hi class, welcome back to lab. We're going to start our lab on measurement and uncertainty. So you'll find this under the class. Make sure you print off the lab instructions. It's called measurement and uncertainty. Make sure you read the background information and your overview, so you can be familiar with the concepts that you are addressing in this lab. I wanted to jump on here for a little bit and review a couple important things within measurements and the lab. So the first thing is I just wanted to bring up the materials that you will need. So the materials come from your Principles of Chemistry equipment set, and you need your scale. So your scale is in a white box, okay, and it has batteries, so it looks something like this. Once you pull it out of the box, you have to insert the batteries in the back, and we're going to review on how to use that here in a minute. You need your 10 milliliter graduated cylinder. So these are plastic. A lot of the time in chemistry lab, these are glass, but that's the 10 milliliter graduated cylinder. You need your 50 milliliter graduated cylinder. Again, this is plastic. Okay, 50 milliliter graduated cylinder. You need your 25 milliliter Erlenmeyer flask. So this is glass. This is wrapped in plastic and bubble wrap. Okay, so this is called an Erlenmeyer flask, 25 mil. Then you need your beaker, your 250 mil beaker. So this is your beaker. You need 2 plastic cups. Okay, so I got cup here and a cup here. Again, it's in your equipment set. And you need the thermometer. Okay. Now, one thing in your lab, it says needed but not supplied a permanent marker. You can use your supplied black wax pencil instead of a permanent marker if you don't have one. Okay. So for this lab, for the safety procedures, you need to make sure you wear your safety goggles during the entire procedure. Again, these are the goggles that are supplied in your kit. I have my safety goggles on, my safety glasses. Make sure that your area is clean and ready for your lab. Today, mainly we're using water, but still you want your area clean. You don't want to be eating or chewing gum or drinking anything while you are doing your lab. Okay, so I'm going to walk you through some of the steps. So in this lab, there are 3 different activities. So I'm going to start with activity 1 on page 7. Activity 1, page 7. And it says A, determination of uncertainty in the lab balance. Okay, so we're going to look at the balance first. So when you get it out of your box and after you added your batteries, it'll look like this. It has a cover on the top that you have to remove. Okay, so you remove the top cover and this is your balance. Okay, and on your balance, so this top part here, this square shape, this is called the pan, and this is where you put the item that you are weighing. Okay, then on the left hand side, it has a button that says on off, so you press that to turn it on. Okay, and the screen lights up. Okay, it doesn't like it that I'm holding it because it's not ready. So you really have to place it flat. You turn it on. Okay, and the middle button is for mode, but whenever you pull, you turn it on, it'll already be set up for grams. You'll see a small G in the upper left-hand corner, and it says 0.00. So that means 0.00 grams. And that means that it's tiered. You'll see the third button on the right-hand side says tare. Now, tare zeros your balance. So say that my balance wasn't reading 0.0. I could hit tare and it'll make it go to 0. Now, there's another reason that there's a tare button. We're not really using that for this lab, but say I wanted this cup and the weight is displayed on the balance right now. But say I wanted to add 3 grams of water. Well, I could hit tare, and that zeroes my balance. So it zeroes out the weight of the cup on my balance. So then whatever I put in that container is what is being measured. Okay? So that's one of the main purposes for the tare button. Okay? But for this lab, you just make sure before you begin that your balance with nothing on it says 0.00 grams. And if it doesn't, you hit the tare button. Okay? Hopefully that's clear. Okay, so for activity 1, part A, you're going to turn your balance on and you're going to label 2 plastic cups. Okay, I labeled one number 1, another one number 2. Okay, and what you're going to do is you're going to start with cup number 1. Okay, and you're going to place it on the balance. Okay, and you're going to measure the weight of, or the mass of cup number 1. Now you'll want to make sure that you have your data tables out and handy next to your experiments so that you can record your data. So if you look at data table 1, it says determination of uncertainty in lab balance. Okay, so every piece of equipment that we use to measure has a degree of error and uncertainty. And this lab is going to walk you through on how to determine if something is, how much uncertainty and how much precision and accuracy equipment in the lab has. So the first weight, so it says trial 1. And if you'll see the second column there, it says cup number 1, mass in grams. Okay, and so you're going to record, so mine says 10.00. Okay, let me turn that back on. Okay, then I'm going to remove it. And I'm going to take the weight so I'm going to zero my balance, then take the weight again. Okay. So record your weight, 10.00. Then the second weight, 10.01 is what my balance reads. Okay, I'm going to do this a total of 5 times for cup number 1. Okay, so I'm not going to do every trial, but you'll measure it 5 times. You will weigh cup number 1 5 times. Then what you'll do is you'll take cup number 2, okay, and you'll place it on your balance after it's 0. And mine says 10.04. Okay, so you record that, 10.04. Remove it from the balance, weigh it again. Okay, this time, again, it's 10.04. Okay, so you'll do the weight, you'll record the mass for cup number 2 5 times. Okay, so I'll let you guys do that. All right, so after you have obtained the mass of cup number 1 and cup number 2 5 times, Then what you're going to do is you're going to calculate the average. Okay? So if you see in your data table 1, under the column labeled cup number 1, mass in grams, so you have your trial 1, 2, 3, 4, and 5, and then you have average. Okay? So the average is going to be, you're going to add up the mass of cup number 1 for trial 1, 2, 3, 4, 5. So you're adding those numbers together. You're going to get the total, the sum of those numbers. Then you're going to divide it by 5, since there's 5 values to get the average. Okay? So you're adding up the total of the 5 trials and dividing by 5. Okay? So I've done one, and my average came to be 10.00. All right? Then you're going to do that for cup number 2 also. So you see that, let's see, 1, 2, 3, 4th column there. So you have the mass of cup number 2, the 5 trials. You're going to add those numbers together, the 5 numbers, the 5 masses, and then you're going to divide by 5, okay, to get the average. So once you have the average for cup number 1 and cup number 2 mass, then you're going to calculate, see the 3rd column, it says cup number 1 deviation from average gram, okay? So in the background, it talks about how to calculate a deviation from average. And how you do that is you take your average mass of your cup, so what you found in the last part of column 2 for cup number 1, so mine was 10.00, and you're going to subtract that from the mass of the cup in that particular trial. So my first trial was 10.00 grams. My average is also 10.00 grams. So I'm going to take 10.00 grams, my average, minus the mass of my cup in the trial, which was 10.00, and take the absolute value. So if you get a negative value, you're going to make it positive. Okay, so it'll always be a positive number. That's what absolute value means. Okay, so in my first trial, it was 0.00. Now my second trial, let me give you this example. So the average mass of my cup number 1 was 10.00. And then my trial number 2, the mass of cup number 1 was 10.01. So I took the average, the absolute value of the average of my cup, minus the mass of my cup in trial 2, and it is a difference of 0.01, which is the absolute value, because it would have been a negative number, but with absolute value, it's a positive. Okay, so once you have calculated the deviation from the average for each trial, down at the bottom, do you see where it says average? You're going to average the deviation from the average. So you're going to take, for trial 1 through 5, you're going to add those together and divide it by 5. And it's going to give your deviation. So in my calculation, my average deviation from the average was 0.01. So what that means is that I have an average mass of cup number 1 at 10.00 with a plus or minus deviation of 0.01. Okay, so that way you can calculate the amount of uncertainty in your lab balance. You'll do the same thing for cup number 2, and you have the last column, the deviation from the average in grams for cup number 2. Okay, and you will calculate that the same exact way. Okay, and then you'll answer the question 1 regarding average deviation. Okay, so the uncertainty of the lab balance is the same based on that particular balance, okay? So it's the same regardless of the actual mass of the item that you're weighing. Okay, so that's Activity 1, Part A. So I want you to note Table 1 on page 7 because you're going to use that here in a little bit for the next activity. Okay, so Activity 2 on page 8. Okay, B, Activity 2B, determination of uncertainty in common glassware. Okay, so now we're going to determine uncertainty within laboratory glassware. Okay, so we're going to have our balance on and make sure that it is 0.00. If not, we're going to press the tare button. Okay, so what we're going to do is make sure you pull out Data Table 2, Determination of Uncertainty in Common Glassware. So this is where you're going to use the 10 ml graduated cylinder, the 50 ml graduated cylinder, the 25 ml Erlenmeyer flask, and the 250 milliliter beaker. Okay, so what you're going to do is you're going to start with the 10 milliliter graduated cylinder. Now mine has water in it, but the first measurement will be without any water, okay? So that's going to be the mass of the empty glassware. You're going to record the mass. I did this previously, so pretend like this doesn't have any solution. I'm recording the mass, and it was 25.25 grams. Okay? Now, you're going to refer to Table 1 on page 7. Okay, so you might want to write above your data table too. In the 10 ml graduated cylinder, you're adding 7 milliliters of water. Okay, for the 50 milliliter graduated cylinder, you're adding 24 milliliters of water. In the 25 milliliter Erlenmeyer flask, so that's this little guy, you're adding 17 milliliters of water. The 250 milliliter beaker, which is here, you're adding 35 milliliters of water. Okay, and it explains that on Table 2 on page 7. Okay. So before you add the water, though, you're going to record the mass, or the weight, the weight on the scale of that glassware. Okay, without any solution in it. Okay, let me do the beaker. Okay, so my beaker was 37.58 grams. Okay, before I add the 35 mils of water. Okay, so we're going to walk through. The 10 milliliter graduated cylinder. And you're going to do the 50 milliliter, the 25 milliliter Erlenmeyer, and the 50 milliliter beaker on your own. I'm going to walk you through some of the calculations. Okay, so on the 10 ml graduated cylinder, you're adding 7 milliliters of water. Now, the second row there, it says estimated volume of water. So on your graduated cylinder, you're going to add approximately 7 mils, okay? And each graduation is 0.2 milliliters, okay? And my graduated cylinder, when I added approximately 7 mils of water, is actually at 7.1 milliliters. So I'm going to bring this closer so maybe you can see that a little more detailed. Okay, so that's about 7.1. Now I'm going to go through how to read 7.1. So if you can see the water kind of dips down. You see that? The bottom part of that water level, of that dip, is called a meniscus. Okay? And you read the bottom dip of that water. Okay? And it shows that to you in your pre-lab instructions, the meniscus. But you read the bottom part of that loop. It's almost like a U. It almost forms a U. And you're reading the very bottom of the U. So this is 7.1 milliliters. Okay? So that's the estimated volume of water. Now the next line there, it says high volume interval. So that is the graduation that is right above it, the exact graduation, which is 7.2, because the graduations are at every 0.2 milliliters. Okay? And the lowest interval is the interval right below that. So on your graduated cylinder, it's 7.0. Okay, so for the high volume, it's 7.2. And for the low volume, it's 7.0 milliliters for the 10 mil graduated cylinder. Okay, so then the next line, it says uncertainty. Okay, so that's a calculation. And how you calculate uncertainty of your 10 mil graduated cylinder or any of these glasswares, okay, you're going to take your high volume interval, okay, in this case was 7.2 milliliters, and you're going to subtract your low volume interval, which with the 10 mil graduated cylinder was 7.0 milliliters, and then you're going to divide it by 2. So it's the high interval minus the low interval divided by 2. And the uncertainty for my graduated cylinder was 0.1 milliliters. Okay. Then the next line is the mass of the glassware with water. Okay. So you're going to weigh it with the water in the graduated cylinder. So you make sure your balance is at 0.00, and you're going to collect your mass, which is 32.33 grams. That's for mine. Your numbers are going to be different, okay, because it'll be not exactly the same graduated cylinder. Okay, so 32.33 grams. Okay, then the last line says mass of water. Okay, so how you determine the mass of the water is you're going to take the mass of the glassware with the water. Okay, so that's this mass that we just took, minus the mass of the empty glassware. So that was the first line, the mass of the empty glassware, when we weighed it without the water. And if you subtract those two, so the mass of the glassware with the water minus the mass of the glassware without water, it's going to give you the mass of just this water. Okay? And in my experiment, it was 7.08 grams. Okay? So that's how you're going to do it for each of the other glasswares. Now, let's look at the 50 mil graduated cylinder. So you're going to take a weight, a mass of it, of this cylinder without water. You're going to add about 24 milliliters, okay? And when I did mine, it's like 24.8, about 80, and of course the last digit is an estimate, okay? 24.80 milliliters. Now, the 50 mil graduated cylinder, the increments are by 1.0 mils. So the high value, the high volume interval would go up to the 25, and the low interval goes to 24 milliliters. Okay, and then of course you'll be calculating the uncertainty. So I'm going to try to bring this around so you can kind of see the meniscus in the 50 mil. Okay, so you can kind of see the meniscus. It's 24.80 mils. All right, now the Erlenmeyer is next. Okay, again, you're going to take the weight without any water. And this Erlenmeyer is a 25 milliliter Erlenmeyer, and it's glass, and you're to add 17 mils. But the tricky thing about this is that there's only graduations at 2.5 milliliters and 25, so you really have to eyeball it and do the best you can. And you will be able to get your intervals. So from 17, your highest interval would be at 20 mils, and your lowest interval at 14, because there is not many graduations on your Erlenmeyer. Okay. Then for the last one is for the 250 milliliter beaker. Okay, so you're going to weigh it before. You're going to add 35 mils of water. Okay, and your high volume interval, so your high basically interval is going to be 56, okay, and you're low at 52, because the graduations are not, they don't start below 50, okay, so use the high and low intervals on the beaker at 56 mils for the high and 52 for the low volume interval. Okay, and you're going to calculate the uncertainty and the mass of the water. Okay, so that's for activity 2. All right, so now we're going to move into activity 3, determination of the accuracy in common glassware. Okay, so you're going to use your thermometer. I just had this thermometer sitting out in the room, so to collect the room temperature. Okay, and you're going to want to read to 1 decimal place. Okay, and my room temperature is 22.0, and this thermometer is in Celsius, so 22.0 degrees Celsius. Okay, so you're going to record that on data table 3, determination of accuracy in common glassware. So it's actually the second line. It says current water temperature. So you write in your temperature of your room. Mine's 22.0. Okay. So then what you're going to do. Okay, so now turn to page 9. There is a table 2. Looks like this. Okay. And it tells you the density of water at certain temperatures. Okay. Now, we're making an assumption in this lab. We're just assuming that the water that we've used is at room temperature, okay, at the same temperature. So that is an assumption that we're using. Okay, so for the density of water, so how you use this table is you find your temperature. So mine was 22, so I'm going to go down to 22. And then you're going to go over to the decimal place that you have. So mine was 22.0. So mine would be the first column at the density of 0.9978 grams per milliliter. Okay. Now let's say that my temperature was 23.3. Okay. So you go down to 23 degrees Celsius, and then you're going to move to the right across that line to 0.3, where at the top it says grams per milliliter plus 0.3 degrees Celsius. And that says 0.9975, which is grams per milliliter. Okay, so that's what I would record. If my temperature was 23.3, I would record 0.9975. But my room temperature is 22.0. So I'm recording on the line that says density of water at room 0.9978 grams per mil. Okay, from my table. All right. Now, let's I know I went down to the second and third line. Let's deal with the first line. Okay. So the first line is, it says the mass of the water in activity 2. So you're going to pull your data table 2. Okay. And that last line that says mass of the water, you're simply copying those values over into data table 3. Okay. So, for example, on my 10 milliliter graduated cylinder, the mass of my water was 7.08 grams. So, on data table 3, for the 10 mil graduated cylinder, the mass of the water in activity 2, I put 7.08 grams. Okay, you're just simply filling in these values that you calculated in data table 2. Okay, then that leaves the last line in data table 3. And this is the calculated volume of water. Okay, and over in your activity 3 directions, it talks about how volume equals mass over density. But I want to just talk about it just briefly. Okay, as you recall in lecture, density equals mass over volume. So what they've done is they've taken that formula for density equals mass over volume, and they've rearranged it using algebra, okay, to rearrange it so they could solve for volume. And they rearranged it where volume equals mass over density. And the units, so that'll cancel your grams, and you'll be left with milliliters. Okay, so what you're going to do is you're going to take your mass in line 1, the mass of the water in activity 2 on line 1, divided by the density from the table on page 9. So, for example, my 10 milliliter graduated cylinder had a mass of 7.08 grams. I'm going to take 7.08 grams, and my density of my water at room temperature was 0.9978 grams per mil. So I'm taking 7.08 grams divided by 0.9978 grams per mil to calculate volume. I'm going to divide that, and that gives me 7.10 mils. So that's the calculated volume, okay, of the water. Now, let's think about this in regards to accuracy, okay? So the accuracy is the difference between the mass of the water, so the first line, mass of the water in activity 2, minus the calculated volume of the water. And that's an absolute value. Okay, so it's going to be a positive. So in this case, it's 7.08 grams minus 7.10 grams. So that difference is 0.02. Okay, so that has a pretty good accuracy on the 10 milliliter graduated cylinder. So once you calculated the volume of water for the 50 ml graduated cylinder, the 25 ml graduate Erlenmeyer flask, the 250 ml beaker, basically subtract and compare the values that you've between the mass of the water in activity 2 to the calculated volume of the water, and see those differences to see which glassware between the 10 ml, 50 ml, 25 ml Erlenmeyer, 250 ml beaker, which one is the most accurate. Okay, then you're going to answer question 3, and you will be completed with this lab. If you have any questions, please let me know. Have any concerns, call, email, text, please reach out. I hope you guys are enjoying the labs. I sure am, and I will look forward to seeing you next time in lab. Thank you.